The ocean is a realm of slow motion. It is a world where movement is difficult, where stealth is life and speed is almost impossible. For 100 years, the physics of naval warfare have remained unchanged. Submarines are silent hunters. They creep through the dark at 10 or 20 knots, hiding in thermal layers, listening for the enemy. If a torpedo is fired, it is a slow, relentless chase. You have minutes to react. You have time to run, and you have time to pray. But in the late 1970s, American intelligence officers began hearing a sound that shouldn't exist. It did not sound like a normal propeller. It sounded like a roar. It moved so fast that their computers couldn't track it. It traveled 1 mile in 18 seconds. It was moving at 200 knots, nearly 230 miles per hour. This was impossible. According to the laws of fluid dynamics, nothing can move that fast underwater. Simply the water would crush it. The friction should melt it. But the Soviet Union had found a loophole in the laws of physics. They did not build a better swimmer, they built an underwater plane that flies inside its own atmosphere. This is the story of the VA-111 Shkval, the weapon that broke the speed limit of the ocean by deciding that water was simply in the way. Now, to understand how the Shkval works, we first have to understand the enemy. In this case, the enemy is not the American Navy. The enemy is water. You see, water is a brutal medium. It is 800 times denser than air. Walking through water feels heavy. Running is impossible. Imagine trying to move at the speed of a race car. As you accelerate underwater, you face two barriers. First, viscous drag. Water molecules are sticky. They cling to the skin of the torpedo, pulling it back. Second, and more dangerous, is cavitation. When a propeller spins too fast, the pressure on the back of the blade drops so low that water literally rips apart. It boils at room temperature. This creates pockets of vapor, bubbles. And when these bubbles collapse, they create shock waves so powerful they can chew through solid steel. For a century, naval engineers fought to prevent cavitation. It was always a sign of failure. It meant you were going way too fast. However, in a secret laboratory in Kiev, Soviet engineers asked a radical question. What if we don't fight the cavitation? What if, instead, we surrender to it? What if we create a bubble so big that it swallows the entire torpedo? This is the cavitator. If you look at the nose of the Shkval, it looks wrong. It isn't a sleek, pointed needle like modern submarine. It is blunt. It ends in a flat, circular disc. However, this disc is the key to the magic. When the torpedo launches, that flat disc hits the water with immense force. It deflects the flow outward, creating sharp separation point. Behind the disc forms a low-pressure void. If this were to be a normal object, the ocean pressure would crush that void instantly. The water would rush back in. But the Shkval has a trick up its sleeves. Inside the nose cone, there is a gas generator, essentially a modified rocket exhaust. It pumps a massive volume of hot gas through vents in the nose, directly into the void. It artificially inflates the cavity. It creates a stable, elongated bubble of steam and exhaust that stretches all the way to the tail of the weapon. Suddenly, the physics change. The metal skin of the torpedo is no longer touching the water. It is flying through a pocket of gas. Skin friction drag drops to near zero. The density wall vanishes. The Shkval is now a missile flying through air, buried 1,000 feet beneath the waves. But this creates a new engineering problem. How do you propel it? You see, standard torpedoes use propellers, but the propeller needs the water to push against. If the Shkval is inside a gas bubble, a propeller would just spin pointlessly in the air. It would be like swimming in an empty pool. Well, it turns out that the Shkval doesn't necessarily need propellers to move underwater. You see, the Shkval is the only torpedo in the world that is powered by a solid fuel rocket motor. It is, quite literally, an underwater rocket. The thrust required to initiate the cavitation is immense. The launch sequence is violent. The torpedo is ejected from the tube, and then the main rocket ignites. It burns kilogram after kilogram of high-grade propellant, blasting a jet of fire out the back. And this what leads to the weapon's biggest drawback: noise. You see, a standard American Mark 48 torpedo is designed to be quiet until the last moment. The Shkval is as loud as an airplane engine. When a Russian sub fires this weapon, every sonar operator in the Atlantic knows about it instantly. It is so loud it deafens its own submarine sensors. But despite all that, the Soviet doctrine was simple. There is no need to be quiet. There's only need to be fast. Now imagine you are flying inside this bubble at 230 miles per hour. You need to turn. A normal rudder works by deflecting water, but the Shkval's rudder is inside a gas bubble. It has nothing to grab onto. If you try to turn the nose too hard, the bubble might collapse and the water will slam into the side of the torpedo at 200 knots, tearing it apart. So how to steer this torpedo? The Shkval uses a system of extendable ventilation skids. Think of them as metal fingers. When the guidance computer wants to correct the course, it pushes one of these fingers out of the gas bubble. The metal tip gazes the wall of water rushing past at supersonic speeds. The drag from the single touch creates just enough friction to nudge the torpedo onto a new path. Because of this, the Shkval cannot hunt. It cannot circle. It cannot weave. It is a straight-line brawler. It was designed for a knife fight in a phone booth. If a US submarine surprised a Russian sub, the Russian captain would fire the Shkval down the bearing line. It forces the enemy to cut the wires of their own torpedoes and run for their lives. It is a weapon of panic. For decades, Western analysts thought supercavitation was a myth. They believed the control problems were unsolvable. But the Shkval proved that with enough brute force and clever geometry, you can negotiate with the laws of physics. And today, the technology is evolving. Germany, Iran, and China are all developing guided supercavitating weapons. The dream is no longer just a torpedo. The dream has gotten bigger. The dream now is an underwater submarine fighter that can cross the Pacific in hours. And that's how the ocean, once a place of slow crushing silence, is becoming a highway for hypersonic speed. So the next time you look at the ocean, remember, it's not just water. It's a barrier waiting to be broken. Standard engineering teaches you to respect the laws of physics. But on this channel, we study the machines that negotiate with them. If you want to see what else is considered impossible right up until the moment it happens, subscribe to our channel. Thank you for watching.